Hello, good afternoon, everybody. Good afternoon, ladies and gentlemen. My name is Rosmaina. I am from Department of Agrotechnology, Faculty of Agriculture and Animal Science, State Islamic University of Sultan Syed Qasim Riau. Today, I want to share about my research with the title Impact of Heat Stress on Germination and Seedling Growth of Chili Pepper or CAPSICUM. This is my team. My name is is Rosmaina, and then Delis Utami, Ervina Arianti, and Mr. Jovahmi. Uh, we know the climate change is a cause the worst abiotic stress such as high temperature, drought stress, salinity, flooding. But we focus in heat stress. Why? Because heat stress have a direct effect on morphological change, physiological change, phenotypic change, and your reduction of many plants. The response of heat stress on the plant depends on temperature, species, genetic use, phase of plant growth, and exposure duration. The germination stage and seedling development have an important role in crop sustainability. We know heat stress on germination phase have a negative effect in many plants like rice, white, maize, and sorghum. But until now, no report about the effect of high temperature stress in the germination phase of chili pepper. So, this study aimed to know the effect of temperature stress on the shoot growth, root growth, and physiological character of chili at the germination stage and seedling stage. This is the method how the research we design. Okay, the experiment was laid out in following factorial completely randomized design consisting of two factors. The first factor was temperature with five level of temperature, and the second factor is stress duration, that is 4 hours, 8 hours, and uh, 12 hours. Each treatment is consisted of 100 seeds of coffee variety. Coffee variety is a local variety from the west of Sumatra. And then the seed is soaked in the water bed according to the temperature and exposure duration treatment. Furthermore, the seed are transferred to the seedling medium with daily temperature, and then after 7 days old, the sprout were transferred to seedling tray. The parameters observed were percentage of germination, shoot length, root length, the number of fruit, fresh weight, dry weight, seedling height, the number of leaf, and chlorophyll content. Let me see the result. This is percentage of germination or germination rate percentage, where high temperature stress treatment with various duration of export resulted in the seed germination percentage of 65 to 98% at 5 days after sowing. The result of this study saw the lower temperature decreased the percentage of germination and caused a delay in germination. Because at low temperature, the process of imbibition and protein synthesis in the embryo also occur slowly and gradually. How about shoot length? High temperature stress, exposure duration, and both interactions significantly different in all parameters like shoot length, number of leaf, height of seedling, root length, number of fruit, fresh weight, and chlorophyll content. Shoot length, in the shoot length, the highest of shoot length was found in the control, which ranged from 2.36 to 2.39 and was significantly different from others, while the temperature at 35 degrees Celsius after 8-hour exposure produced the shorter shoot, that is 1.55 centimeter or reduction of 35.15%. Let me see in the figures. In the figure, the rise temperature significantly reduced the shoot length range from 15.90 to 15 30.50 compare the control plane. And then this is number of leaf. The highest number of leaf obtained at the temperature 37 degrees Celsius with 4-hour exposed duration was 6.02 leaf per plant, while the lowest number of leaf was obtained in 41 degrees Celsius and 35 degrees Celsius with 12 hours of exposure, and both were not significantly different from others. The decrease in the number of leaks ranged from 4.78 to 30%. We can see in the figure beside of the table. This is except in 37 degrees Celsius, the number of leaves increased 4.78. Then root length. Root length individual, we can see that reduce root length reduce cause of high temperature and time of exposure duration. The highest root length was obtained in control plane, uh, and uh, and the smallest root length was obtained in temperature 39 degrees Celsius with 8 hours of exposure of 1.95 centimeter of lower 23.23%, but it's no significant difference with the treatment 41 degree Celsius and exposure duration 8 or until 12 hours. Uh, Number of roots. Some of treatment cause high temperature cause increased number of roots. The highest temperature stress increased number of roots, especially at 39 degrees Celsius for 12 hours and 41 degrees Celsius for 8 hours, with an average 5.42 and 5.14 root per shoot, or increased 9.80 and 13.47 respectively, and both were higher than control. Temperature and stress duration. The average value chlorophyll B chlorophyll B influenced by temperature and seedling high chlorophyll B drawback influenced by temperature and time of expose, but not interaction uh, between temperature and time of expose. This is the highest of a seedling height and chlorophyll B chloro, dry weight found in control plant, but the highest temperature reduce the seedling height and chlorophyll B, and then dry weight also. Okay, the rise in temperature for all that we explained before above, the rise in temperature and duration of exposure decrease root length, number of root, fresh weight of seedling, number of leaf, and chlorophyll content. The reduction of chlorophyll content has a significant correlation with degradation in the photosynthesis rate and has an impact on loss of yield and biomass. Kumar et al. Report the decrease of chlorophyll content from 2.61 to 8.40% will reduce the photosynthesis rate of 20.42 to 38.42%. So increased temperature reduce photosynthetic activity through decreasing chloroplast pigment in leaf structure, demand of pigment protein complex, and activity on photosystem 2, and inhibition of the electron transfer and some of the enzymatic activity required for the photosynthesis, and then damage the thylakoid and structure in chloroplast and stomata. That is so many report about it. So we conclude based on our result that germination stage is susceptible to high temperature stress due to reduced in shoot development, root development, and physiological character of chili pepper. Okay, this is my presentation. Thank you for your attention. Thank